Welcome to the deep dive. Today we're really getting into JavaScript.
Yeah, the language that basically makes websites do stuff, right? Makes them interactive.
Exactly. And we've got a whole stack of sources stuff on the history. The DOM. What's the DOM again?
Document Object Model. We'll get into that.
Okay. Plus beginner guides, patterns, functional programming bits, even testing JavaScript.
So our mission today is really to unpack all of that for you.
Right.
We want to give you a clear, kind of engaging picture of what JavaScript is, how it connects with HTML, how it can change web pages.
Dynamically.
Yeah, dynamically. And even touch on some, more advanced ways to think about organizing your code.
So getting the important stuff without getting totally lost in the weeds.
Precisely. Keep it practical, keep it relevant so you can learn quickly.
Okay, let's start at the beginning now. JavaScript's origin. It's kind of interesting, isn't it?
It is 1995, Netscape.
And it wasn't even called JavaScript at first.
No, LiveScript, which, maybe makes more sense. But yeah, JavaScript was the name that stuck. And it caught on fast.
People quickly saw how essential this kind of scripting would be for the web.
Definitely.
Oh.
But then you had different browsers popping up, Netscape, Microsoft with Internet Explorer, and they needed a common standard. Otherwise, chaos.
Right. Write code for one browser, it breaks in another.
Yeah.
Nightmare.
Exactly. So that's where ECMAScript came in ES. ECMA International formalized it.
So ECMAScript is the standard. JavaScript is like the main implementation.
Pretty much, yeah. It ensured that code, generally worked across browsers. Microsoft called their version JScript, but it followed the same ECMAScript standard. It was crucial for interoperability.
Okay, so what makes JavaScript?
What?
JavaScript. The sources call it lightweight. Interpreted.
Interpreted means it's generally processed line by the browser, not compiled into machine code beforehand like some other languages.
Okay. And designed for network-centric apps, works with Java and HTMLs.
Right. It was always meant for the web environment. And being open, cross-platform, that really helped it spread.
So how do we actually, put JavaScript into a web page?
Script tag. That's the fundamental way.
Right inside the HTML.
You can put your code directly between script and script. Fine for tiny bits.
But not for big stuff.
No, definitely not. For anything more complex, you link to an external JS file using the src attribute in the script tag.
Like script src mycode.js script.
Exactly. Big advantage, .reusability. Write it once, use it on many pages, keeps things much cleaner, easier to manage.
In readability. Even though the browser doesn't care about extra spaces or new lines, we do, right?
Oh, absolutely. Use white space, use indentation. Makes a huge difference for understanding the code later.
And comments. Essential.
Totally. For a single line.
Or for multi-line comments.
Yep. And you might even see the old HTML style .dos sometimes in really old code. JavaScript kind of treats it like 8-byte.
Huh. Okay. So what about the actual data? What does JavaScript work with?
We've got primitive types. These are the basics.
Like numbers.
Numbers, yeah. And JavaScript doesn't really fuss about integers versus decimals. They're all just number.
Okay. What else?
Strings, that's text. Sequences of characters.
Right.
Booleans, just true or false.
Simple enough.
And then null and undefined. Both kind of mean nothing, but they're slightly different. Undefined usually means a variable has been declared but not given a value yet, while null is often used intentionally to represent the absence of a value.
Okay. Subtle difference.
Yeah. And then the big one, object. Objects are more complex, like containers for collections of data, maybe other objects, even functions.
So primitives are the simple building blocks. Objects are more like structures built from them.
That's a good way to think about it.
And we store this data in variables.
Yeah.
I see var used a lot in older code and some sources.
Right, var was the main way for a long time. You declare a variable, like var my variable or var my number 10.
No, but there are newer ways now. Let in const.
Exactly. Introduced later in ES6. They have better scoping rules, which helps avoid some common pitfalls you could run into with var. We should probably stick to let and const in modern code. Const is for values you don't intend to reassign.
And JavaScript is untyped. What does that mean?
It means a variable isn't locked into holding just one type of data. You could have let my var equals 10 and later say my var hello. The variable can hold different types over time.
That sounds flexible, but maybe confusing.
It can be if you're not careful. It ties back to that idea of scope, especially with var.
Scope being where the variable is accessible.
Right. With var, it's usually function scoped. meaning a variable declared inside a function is accessible anywhere within that function.
Not block scope like let and const.
Correct. Let and const are block scoped, meaning they're only accessible within the curly braces where they're defined, like inside an if statement or a loop. This is generally more intuitive.
And what's this hoisting thing with var?
Hoisting. It's a bit of JavaScript weirdness. With var, it's like the declaration of the variable, but not its assignment, gets moved to the top of its function scope before the code runs.
So you could technically use a variable before you declare it with var.
Sort of, yeah, but it would be undefined at that point. It's generally bad practice. The best advice is just declare your variables at the top of their scope anyway, especially if you're forced to use var. Let and const behave more predictably. They aren't hoisted in the same way.
Okay, got it.
Yeah.
Stick with let and const where possible. Last fundamental bit. Operators. Like the equal sign.
Yep, that's the assignment operator. Assigns a value to a variable.
And then those shorthands. Plus.
Compound assignment operators.
Yeah.
Super handy. X plus 5 is just a shorter way of writing x plus 5.
Same for multiplication, division, remainder, percent.
Exactly. Just makes the code a bit more concise.
Okay, fundamentals down. Now, the DOM. You said document object model.
Right. So think about your HTML page. It's structured, right?
Yeah.
Headings, paragraphs, lists, images.
Nested inside each other.
Exactly. The DOM is the browser's internal representation of that structure. It takes your HTML text and builds a logical tree out of it in memory.
A tree.
Yeah, like a family tree. There's a root, which is the document itself, then the HTML element that branches into head and body.
And under body, you have all the visible stuff. H1, P, div.
Precisely. Each element is a node in this tree, and this tree structure is what allows JavaScript to find and interact with specific parts of the page.
So JavaScript uses this DOM tree to, what? Change things.
Exactly. It can find elements, change their content, change their attributes, even add or remove elements completely. It's how web pages become dynamic.
How does it find the elements?
Several ways. A really common one is document.getElement by id, some id. HTML elements can have unique element attributes.
So you target a specific element.
Yep. Or you can get multiple elements, like all elements with a certain CSS class, using document.getElements by class name, some class.
So it gives you a collection.
Right, an HTML collection. It's like an array, but it's live. If you add another element with that class later, the collection updates automatically.
Okay. Are there other ways?
Oh, yeah. More modern and often more flexible are document.querySelector and document.querySelectAll.
Query dot like CSS?
Exactly. You use CSS selectors.className, hashtag IDName, tag name, even complex ones like divp.
Oh, that's powerful.
Very. QuerySelector gets the first matching element. QuerySelectAll gets all matching elements as a node list.
A node list, is that live too?
Usually not. It's typically a static snapshot of the elements that matched when you ran the query.
Okay. So once you have an element, you can move around the tree?
You can. From an element node, you can get its child nodes, a node list of all its direct children, including text nodes and comments sometimes, or just the first child or last child.
Navigate down. Can you go sideways or up?
Yep. Next sibling and previous sibling let you move between nodes at the same level, and parent node takes you up to the element that contains the current one.
Got it. And there are shortcuts.
Yeah, document.body directly references the body element, and document.documentElement gets you the root HTML element. Saves a bit of navigating.
So it can find elements, navigate around. What about changing them? Attributes, for instance.
You can manipulate attributes easily. Element has attribute checks if an attribute exists.
Like on a link.
Right. Then element.setAttribute, http.new-url.com, adds or changes an attribute's value.
And removing them.
Element.removeAttribute. A ref. Simple as that.
How do you get the current value?
Element.getAttributeRef. Important note here. If an attribute exists in the HTML but has no value, like input type text disabled, getAttribute disabled, will return an empty string, not null.
Ah, good to know. Empty string, not null.
Yeah, common little trip up.
Okay, attributes are one thing. What about actually adding or removing elements, making new stuff appear on the page?
That's where the real dynamic power comes in. You can create brand new elements with document.createElement.ip or document.createElement.
Just makes the element in memory.
Right, it doesn't appear on the page yet. You can also create text with document.createTextNode. Some text here.
So you have these new pieces. How do you put them on the page?
You need to append them to an existing element in the DOM tree. The most common way is parentElement.appendChild, new element. That adds the new element as the last child of the parent element.
Always at the end.
Append child does, yes. But you can insert it somewhere specific using parent element.insert before new node, existing node. Puts the new node right before the existing node.
Okay, more control. Can you replace things?
Yep. Parent element.replace child, new node, old node. It swaps old node out for new node. And interestingly, it gives you back the old node you just removed.
And just removing something.
Parent element.remove child, child node. Straightforward.
What about inner HTML? I hear about that a lot.
Inner HTML. It's a property on elements. You can use it to get or set the entire HTML content inside an element as a string.
So you could just wipe out everything inside a div and replace it with new HTML.
Exactly. My div.innerHTML equals h2 new title 2p new paragraph.b. It's very convenient.
But there's a catch.
There can be, yeah. Security. If you're setting inner HTML using text that came from a user or an external source, you have to be very careful. Someone could potentially inject malicious script tags into your page.
Ooh, right. Cross-site scripting, XSS risk.
Precisely. So powerful, but use with caution, especially with untrusted content. Often using methods like create element, create text node, and append child is safer, though maybe more verbose.
Okay, makes sense. So we can manipulate the page structure. How does JavaScript decide when to do things? Control flow.
Right. Conditional statements are key, making decisions.
Like if statement.
Exactly. If condition, do this if true.
Yep, if condition.
Do this if false.
What if you have
multiple ifs? If it's condition 2, if nothing else matched, you chain conditions together.
Okay. What else? Switch. When would you use that?
Switch is good when you have one value, and you want to check it against several specific possibilities.
Like checking the value of a variable called day of week.
Perfect example. Switch, day of week, case Monday, break, case Tuesday, break, default.
The break is important there, right?
Crucial. If you forget break, it falls through and executes the code in the next case as well, which you usually don't want.
Got it. Break stops the fall through. Okay, what about doing things repeatedly? Loops.
Loops are fundamental. The while loop is pretty simple. Well, condition is true. It keeps going as long as the condition stays true.
Good if you don't know exactly how many times you need to loop.
Exactly. Maybe you're processing items until you find a specific one.
And the for loop.
For is more structured, often used when you know how many iterations you need, or when iterating over something with a known length, like an array.
It has that setup part, the condition, and the update part.
Right. For let I is 0, iArray.length, I plus update. You initialize a counter, iArray.length, and define how the counter changes each time, I plus plus. Very common for arrays.
What about objects? Can you loop through their properties?
Yes, using the for.in loop. Let key in my object. Use my object key. It iterates over the property names, keys of the object.
So you mentioned something important about for.in earlier. Has own property.
Yes. Very important. Objects in JavaScript can inherit properties from their prototype. For.in will loop through all enumerable properties, including inherited ones.
Which might not be what you want.
Usually not. So inside the for.in loop, you should always check if my object.has own property. Okay, this property belongs directly to my object. That filters out the inherited stuff. Good
practice. Okay, are there ways to break out of loops early?
Yep. The break statement, we saw it in Switch, but it also works in loops from. It exits the loop immediately.
What if you just want to skip the rest of the current iteration and go to the next one?
That's continue. It jumps straight to the next cycle of the loop.
In return, that exits a function, right?
Correct. Return exits the current function. It can also send a value back to the code that called the function, return result.
And just calling a function disrupts the flow too, doesn't it?
It does. The script jumps to the function's code, runs it, and then comes back to where it left off.
Okay, let's talk more about functions themselves, the reusable blocks of code.
Exactly. Super important for organization, avoiding repetition. You define a block of code once, give it a name, and then you can call it whenever you need it.
How do you define them? I see function, my function.
That's a function declaration. It starts with the function keyword, then the name, parentheses for parameters, and curly braces for the code block.
And function expressions.
That's when you define a function as part of an expression, often assigning it to a variable like let my function function.
Can those be anonymous? Without a name?
Yes. Let my function function, no name here. Very common, especially with callbacks.
You mentioned hoisting earlier. Does that apply to functions?
It applies to function declarations. You can call a declared function before its actual definition appears in the code.
But not function expressions.
No, expressions assigned to variables using let or const aren't hoisted like that. You have to define them before you call them. Another reason let and const are generally preferred.
Okay. Functions take inputs, parameters.
Right. Defined in the parentheses, function greet name.
Yeah.
When you call it, you provide arguments. Greet Alice.
And they give back outputs using return.
If you want them to, yes. Return sends a value back. If there's no return statement, the function implicitly returns undefined.
Can you have functions inside functions?
You can, nested functions. They have access to the variables in their outer functions scope, which leads to powerful concepts like closures.
And function literals. That's like the anonymous function expression.
Yeah, basically defining a function as a value itself. You can pass functions as arguments to other functions, return them from functions. They're treated like any other value in JavaScript. First-class functions.
There's also a function constructor.
There is, like a new function, AB, return it plus B. You pass the parameter names and the function body as strings.
Sounds odd.
It is, and generally discouraged. It has security implications because you're evaluating code from strings, and it's usually much slower than regular function definitions. Stick to declarations and expressions.
Okay, good advice. Let's shift gears a bit. Design patterns. These are like reusable solutions.
Exactly. Standard ways to solve common problems in software design. JavaScript's flexibility means some patterns look a bit different than in, say, Java or C++ way, but the core ideas are often similar.
Like the namespace pattern. What's that about?
Avoiding name collisions, basically, especially in larger apps or when using multiple libraries. You don't want your calculate function accidentally overwriting someone else's calculate function.
Did you create a container?
Right. Often just a single global object for your app, var myapp be myapp.utilities, myapp.utilities function. Everything lives inside myapp, keeping the global scope clean.
Makes sense. What about the module pattern?
The module pattern is classic JavaScript. It uses closures, that idea of functions remembering their scope, to create private and public members.
Private. Like stuff hidden inside.
Yeah. You wrap your code in a function, often an immediately invoked function expression, or IIF. Variables declared inside are effectively private. Then you selectively return an object containing the functions you want to expose as the public interface.
So you control access to the internal workings.
Exactly. It's great for encapsulation. The sandbox pattern is a related idea, creating isolated environments for modules to run in safely.
And static members.
Those are properties or methods that belong to the constructor function itself, not to the individual objects created by it. Think of array.isArray. IsArray is a static method on the array constructor.
Okay. And there are broader categories like creational, structural, behavioral patterns.
Right. Creational patterns deal with how objects get created, like factory or builder. Structural patterns deal with relationships between objects, like adapter. Behavioral patterns deal with interactions, like observer, mediator, command. We won't dive deep into all of those, but knowing they exist is useful. JavaScript adapts these patterns.
What about coding patterns?
Yeah.
Smaller scale things.
Yeah, conventions for writing clear, efficient code, like the single var pattern declaring all vars at the top of a function. Less relevant with letconst, but you'll see it.
And using his own property in loops.
Yeah, definitely a key coding pattern, as we discussed. Essential for reliable object iteration.
How else do we create objects besides constructors?
Object literals are super common. Via value, another key. Simple, direct, or new object. But literals are generally preferred. Constructors and prototypes are key for inheritance, though.
Right, the prototype chain. Objects inheriting from other objects.
Yeah, that's fundamental to how JavaScript handles inheritance. Objects have a hidden link to their prototype. And if a property isn't found on the object itself, JavaScript looks up the chain.
And closures again. Functions remembering their environment.
Exactly. Even after the outer function has finished running, the inner function still has access to the outer function's variables. That's the magic behind the module pattern.
Yeah, okay. What about apply and call?
Those are methods on functions. They let you call a function, but explicitly set what this keyword will refer to inside that function. You can also pass arguments differently. Apply takes arguments as an array. Call takes them individually.
Let's have more.
Lots of things. Borrowing methods from other objects, working with functions that expect a specific this context.
And partial application, currying.
More advanced function techniques. Basically creating new functions by pre-filling some arguments of an existing function. Can make code more reusable or composable.
Okay. Quick hits, truthiness and falsiness.
Crucial for conditions. if loops. Which values count as false?
Yeah. False itself.
Yep.
0.
Number 0, yes.
Empty string, null and undefined.
Both falsy.
Nan, not a number.
Exactly. Those 6 are falsy. Everything else in JavaScript is truthy objects, arrays, non-empty strings. Numbers other than 0. True.
Good to remember. Type conversion.
JavaScript often does it implicitly, like adding a number and a string converts the number to a string first. You can also do it explicitly with string, number, boolean.
Okay, moving beyond the core language. The browser object model, BOM.
Right. That's how JavaScript interacts with the browser itself, outside the page content. The window object is the main entry point.
Window is the global object in browsers.
It is. It holds things like location, the URL, history, methods like alert, set timeout, document.default view, also points to window.
Events, how JavaScript reacts to clicks, mouse movements, key presses.
Vital for interactivity. Things like on-click, on-mouse over, on-key press. These are triggered by user actions or browser activity.
There's bubbling and capturing.
Yeah, those define how events travel through nested elements in the DOM. Does the event trigger on the innermost element first and then bubble up, bubbling? Or does it trigger on the outermost element first and travel down, capture?
How do you actually listen for events?
The modern standard way is element.addEventListener, click my function. You specify the event type, click mouse over, etc., and the function to run when it happens. Older IE used attach event.
Can you stop the default browser action, like stopping a link from navigating?
Yep, using event.preventDefault inside your event handler function.
And stop the event from bubbling up further?
Event.stopPropagation.
Okay. Timers.setTimeout.
Set timeout, my function 2000, executes my function after a delay, 2000 milliseconds, or 2 seconds in this case. Executes it once.
Cookies. Storing data.
Small bits of data stored on the user's machine, accessed via document.cookie, often involves helpful functions to parse the cookie string.
Asynchronous operations. This sounds important for modern web apps.
Hugely important. It's about doing things like fetching data from a server without freezing the browser. The user interface stays responsive.
How's that done? XML HTTP request.xhr.
That's the classic way. You create an XHR object, configure it, URL, method like getPost, send the request, and then listen for the ready state change event to know when the data comes back.
And you might get back XML or JSON.
Right. JavaScript has tools to parse both, like json.parse for JSON data.
Modern JavaScript, ES6 and newer features.
Big improvements. Template literals, backticks for strings, make embedding variables way easier. Default parameters for functions, function greet name, it guessed. Destructuring to pull values out of arrays and objects. Name, age, a user object.
Promises. Async await.
Those revolutionize handling asynchronous code. Promises provide a cleaner way to manage callbacks, avoiding callback hell. Async and await build on promises, making async code look almost synchronous and easier to read. Huge quality of life improvements.
And strict mode. Use strict.
Yeah, put that string at the top of your script or function. It opts into a stricter set of rules, catches more errors, prevents some unsafe actions. Generally a good idea to use it.
Finally, testing. Why bother?
To make sure your code works and keeps working when you change things, catches regressions, builds confidence.
What's lean testing?
Keep tests simple, short, focused, easy to understand. Don't make the tests themselves overly complex.
Human readable expectations.
Write your test descriptions clearly, saying what behavior you expect in plain language. Helps document the code too.
Tagging tests.
Categorizing them, like @smoke for basic sanity checks, @API for API interactions. Helps run specific subsets of tests.
Property-based testing.
More advanced. Instead of writing examples, you define properties the code should hold true for any valid input, and the test framework generates lots of inputs to try and break it. Good for finding edge cases.
Wow, okay. We covered a lot there.
We did. From the history and basics through the DOM, controlling flow, functions.
Patterns, browser interaction, async, even testing.
Hopefully, you now have a much stronger foundational grasp of JavaScript and its role.
Yeah, thinking back, some things really stand out, like how it went from LiveScript to the ECMAScript standard so quickly.
And that DOM tree idea, visualizing the page structure.
Right, and how JavaScript can just reach in and change it, create elements on the fly.
The module pattern using closures is pretty elegant, too, for organizing code.
And async stuff, essential for making sites feel fast and responsive today.
Definitely.
So this leaves us with some things to think about, right? Like, where do you actually see the DOM being manipulated on websites you use, those interactive bits?
Good question. And how do modern frameworks like React, Vue, Angular use these core JavaScript and DOM concepts. They build on top of this foundation.
Yeah, they don't replace it. And if you wanted to learn more about, say, promises or specific design patterns, where would you look?
There are tons of great online resources, documentation like MDN, Mozilla Developer Network is fantastic, books too.
And we focused on browser JavaScript, but there's Node.js for the server side. How does that compare?
Uses the same JavaScript language, same core concepts,
Right.
but interacts with the server environment, file system networks, instead of the browser DOM and BOM.
Okay, final thought then. JavaScript is everywhere. It shapes so much of our online experience.
Absolutely.
So, how do you think its role will keep evolving? What's next for JavaScript? And what challenges or new capabilities might we see as it keeps growing?
That's the big question, isn't it? Constant evolution. It'll be interesting to watch.
Definitely something to ponder.
That's
Thanks for
the-
joining us for this deep dive into JavaScript.